Hello, Ken. I'm going to show you how to work the scope. It's been a while since I've used mine, so we'll probably do a little learning together. So let's see, I've got it set for idle speed, and that's where the red LED on the unit is on. Okay, so that means you're below 980 RPM. And my scope, I don't have to use the ground clip because my test setup grounds the scope. It's grounded through, let's see, I forget. Well, let's just hook up a ground just because. Okay. Alrighty. So I got the scope clipped to that grounding screw on the circuit board. Now yours is covered up. So in my email I suggested you add a ground wire to it would be pin 2 on your connector. That's where the black wire comes in. So just add a little wire there so you can clip onto the end of it. Okay, so here I am probing channel 1, and you can see the waveform on the scope. Okay, so I unprobed. There I am back again. And notice that I've got auto set and default pushed in, and the run stop light is lit. And it's a 4-channel scope, and I'm only using channel 1. So if I were to push the channel 2 button, it would turn on. Now see, channel 2 is now lit, and you got another trace up there, but we're going to turn it off. Okay, we're only going to use channel 1. And let's see, the horizontal button. Let's see, okay, it says M, 20 milliseconds. That's 20 milliseconds per square. Okay, and you can, okay. So rotating this lower thumb wheel changes that. And I don't think the upper one does anything. Oh yeah, it does. It moves the display slightly. Okay, so leave that one alone. And then on the scope probe itself, I got it set for ×10. And you push channel 1, and notice it says coupling is DC. And I guess touching that, okay, you can change it to AC or DC. Okay, inverted is off, probe. Okay, so you can choose that you've got a 10x probe. Okay, 20x, 50x. We're going to choose 10x. And this doesn't make any difference really. Okay, and then let's see, turning the top one can raise and lower the trace. Okay, and turning the bottom one magnifies the signal, and you'll see that reflected over here in this square. Okay, so now we're in 5 volts per vertical division. So let's go counterclockwise. Okay, and I think 50 volts per division is the max reading. It'll say 100, but it's not really. Oh, maybe it is. So set that for 20. And you should be able to see your high voltage pulse from each channel. So you can move down the line and check for your high voltage pulse on all of them. You know, over here on the green connector, you can check for all of them. But I don't think you've got a high voltage problem, because when you disconnect one channel, the LED on the gauge starts blinking, a different LED. And then you connect everything back up and it stops blinking, and you got a solid 5th LED on, which is kind of strange. So there's a test point on the gauge on the connector. I sent you a picture. It's a little rectangular hole on the top of the connector. You can probe the signal, okay? And we're gonna have to change the range scale in the scope. So we're gonna go, let's see, we're still in, okay, so we go clockwise. Okay, so now notice on my test gauge, I've got no LEDs lit, okay? And this one doesn't. Oh yeah, we can simulate a problem, can't we? We can disconnect one of the channels. That should turn on. Okay, there we go. So I disconnected channel 8, and notice I've got a blinking 4th LED, just like you do. Okay, when you disconnect, and if you probe that test point. Okay, so there you see pulses that are going to the gauge and making that LED flash. But with just a solid 5th LED on, so we're on 0.5 volt per division, okay, 500 millivolts. So you would see just above 1 square high, a solid line going across. And I can't see a reason for that unless there's either a solder bridge on the gauge itself inside, or on these components that are near the gauge connector. There's some resistors and a Zener diode. And you'd have to know a little bit about electronics to troubleshoot that, but I don't think you've got a coil problem. So you can run the truck as it is. I mean, it works, right? But I'll send you the schematic. And oh yeah, let's see. Yeah, if the short is on the gauge, and you unplug the cable from the unit, okay, so the gauge cable is unplugged, okay, and if you probe that connector again, and you see the solid 0.65 volts, then you know that the problem is on the Vampire circuit board and not on the gauge. Okay, so I'm going to stop this and I'll put it on YouTube.